in this case, we're given two polynomials, p and d, and we are to use either synthetic or long division to divide p of x by d of x, and then write p of x as the divisor times the quotient plus the remainder. This is actually a good way to check our division problems. So in this case, I'm going to be dividing x minus 5 into x cubed plus 2x squared minus 4x plus 6. When we divide the x cubed by the x, we get x squared. 1x squared is the first term in the quotient. Now we take x squared times x minus 5. You don't have to write this down. And that is x cubed minus 5x squared. Now we're going to subtract. The x cubes neutralize each other. 2x squared minus a negative 5x squared will give us 7x squared. 4x minus 0 is negative 4x, and 6 minus 0 is 6. Now, we take 7x squared and divide it by the leading term of the divisor, which is x, and we get 7x. This will be the next term in the quotient. Now we take 7x and multiply it by x minus 5. That'll give us 7x squared minus 35x. When we subtract, we'll get negative 4 plus 35x, which would be 31x, plus 6. 6 take away 0 is 6. Now we take the 31x, divide it by x, the leading term in the divisor. We get plus 31. 31 times x minus 5 will give us 31x minus 155. Six minus a negative 155 will give us 161 as our remainder. And x squared plus 7x plus 31 as the quotient. Now, let's verify before we actually write the answer in the form that we've been requested. Let's verify that if we use synthetic division with the number 5 as our divisor, because in x minus r we use the r, and then we use the coefficients of the terms from p of x. There's no missing term this time. We should get the same answer for the quotient and the remainder if we use synthetic division. Bring down the 1. 1 times 5 is 5. 5 plus 2 is 7. 7 times 5 is 35. 35 plus negative 4 is 31. 31 times 5 is 155. 155 plus 6 is 161. The remainder is 161. The quotient is a second degree polynomial because we started with third degree and divided by a linear factor. 3 take away 1 is 2. So 31 is the x to the 0 term, 7 is the x to the first term coefficient, and 1 is the coefficient of x squared. So when we write the form we've been asked for, p of x should equal d of x, which is x minus 5, times q of x. Up here, our q of x is the same as it was for long division, x squared plus 7x plus 31. So that's what we write here. That's d of x times q of x plus r of x. So this is our answer here. Now, I said this is a good way to check our division, and notice that if I actually do this multiplication and multiply x by each of the 3 terms in the binomial, or in the trinomial, and negative 5 by each, and then add the 161, I should actually get p of x back. So here's how you could check. So it would be x cubed plus 7x squared minus 155 when you multiply, oops, I'm sorry, I did that wrong, plus 31x. That's what happened when I multiplied by the x. And then when I multiply by the negative 5, negative 5x squared, negative 35x minus 155 plus 161. So there's only one x to the third term. There's a 7x squared and a minus 5x squared, which leaves us with 2x squared. There's a 31x minus a 35x, which leaves us with negative 4x. And negative 155 plus 161 gives us plus 6. And we can confirm that this was the original p of x.